Alright, so I'm getting part of a power supply. This is the, I guess, Rev 3 power supply started. I've already done Rev 1 and Rev 2, and Rev 2 works pretty good, but it only has 3 voltage ranges, whereas I need 4. And we were trying to pull 1000 VA out of an 800 VA transformer, and it turns out that although the AnTek transformers are very good, and I typically buy them, they don't supply a lot of headroom past their datasheet values. So if it's 800 VA, you can expect 800 VA. You're not going to get 130% or 150% out of an AnTek toroid. They work great, but their cores aren't big enough to support overdrawing them by 150%. They saturate. Of course, they saturate their transformers. But what I'm trying to say is, typically you can overdraw a transformer by 120, maybe even 150%. But these guys, you can't do that. So we got ourselves a 1000 VA transformer right here. He's huge. He's like, I think 16 pounds. So these are the secondaries. You can believe that. They don't skimp on the wire. That's 10 gauge. I believe that's 10 gauge. Oh, it's 12 gauge. Okay, it's 12 gauge. They do not skimp on the wire, that's for sure. But this transformer doesn't have the outputs that we need for the power supply. And I prefer to have a singular transformer for the power supply, if possible. So he's going to need to be rewound and then re-shrunk tape. I've got the shrink tape for it. This one's what? The lowest voltage was like 35 volts per winding. If you're going to core a transformer, you definitely want to get 25 volts. You definitely want to get a lower voltage output and a higher wattage, because the higher the voltage, it means the more winding you have to pull off. You probably have to pull off the same amount of winding, but the thing is, the lower the voltage, the less turns, so theoretically you can pull off less wire and it's less of a hassle. Because these are 25 volt windings, what we're going to do is we're going to pull it off about halfway, so we'll have 12 volt taps, and that'll give us the 12 volt AC that we need for the power supply taps. They're going to be symmetrical taps. Most of the power supplies have asymmetrical taps, and then they do some logic to select the different taps at the different voltage levels depending on how you turn up the power supply. I'm just going symmetrical, it's easier, and it'll be controlled by an LM334 voltage comparator. Well, actually 334 is just an op amp, but we'll have it situated as a comparator. So we'll have 4 taps. I think we'll have 4 taps. I have to see. I don't know. We'll probably wind this for 6, and we'll probably end up having a high power 5 volt and maybe even a high power 12 volt fixed supplies out on this guy, because it's always good to have auxiliary supplies out on a power supply. You never know when you need logic 5 or 12 volts. Always handy. Oh god, I hate doing this. Make sure when you do this, put 2 holes in. Okay, because if you only put 1 hole in, then cutting this out is very hard. I did that. Make sure you put 2 holes in. That way when you use a saw, you can actually cut out that big center chunk. This is a nightmare. The neighbors hate it when I do this, and I hate when I do this too, because I have to use files. and it's a pain. This thing vibrates really bad, but it looks like, come on, looks like we got it for meter units. Yeah, it's upside down. That should be fun. Anyway, voltage and current. These have to be on their own separate supply buses. So this guy has to have not only power windings, but it also has to have system control windings put on it. So I'm going to put 6 1 amp windings on it, and we'll have 6 high current windings on it, and that'll allow us to have auxiliary voltages for the panel meters, and it'll give us voltages for the relays to switch between the voltage outputs, and potentially I don't know yet, but potentially voltages for auto ranging for the DMMs, so that we get more precision out of the DMMs than they provide. So potentially we can have 2 ranges, possibly 3 ranges on the DMMs, depending on the output. That's a little bit more tricky. That's another comparator. So we'll see if we can do the auto ranging on the DMMs, and I'd like to do that not in an Arduino, but I'd like to do that just in comparators, because you can fiddle with that. It's a little bit easier. So this is the beginning of your power supply Vi. Hopefully the beginning of the end, but this isn't the way it's going to end up. Of course, I would still like to have a chassis professionally made, but we need to see if all the guts are going to fit into the chassis before we make a final chassis, and I think it'll all fit, but I don't know. I might make the parts way too big and they might not fit, so we gotta see. So this is more or less to finish out proof of concept, make sure it'll all fit, and then finalize the circuit boards, and we'll go over that too, so you guys can see what the circuit looks like. And I always thought auto ranging power supplies were really cool because it's magic. So we'll go over that a little bit. I'm not the world's expert on auto ranging power supplies. I've been researching it for a while, and I still can't understand how some of the voltage detection works. I tried to do it outside of a couple of power supplies I have that are well known, and the circuit wouldn't work. So there's some magic going on there that I don't understand. But we'll dive into this a little bit, and we'll see what we can come up with, and hopefully Vi will get this in 4 years. It's 3 years overdue. I'm sorry, Vi. I know. You go ahead and put a bunch of nasty emails out on me. I don't care. It's hard to get this stuff done when you work all the time. So I'm sorry. I know. I've been trying. Lots to do, man. So yeah. So we got our hole for our power switch, holes for our meters. I need holes for the potentiometers, and probably the power out front for the moment. We still haven't decided how we're going to do that yet, but it'll come. So I should probably just buy you a power supply, Vi. It'd be faster. But this is what you get for free, man. It takes a long time. Anyway, that's it for now.